Now that we have finished the rows diagram, we are going to see how to present this data set itself in a bar diagram. The bar diagram is same as what we have done in our school days. Now along the x-axis we are going to plot the trend range in degrees. So I am starting with 0, then we should always write along the x-axis. This is the frequency f, this is the frequency, that means how many such lines were falling within these ranges. Here I can choose a scale 0 to 30 degree, the number is 3, very simple. We have to draw a rectangle, then 30 to 60 degree, the number is 3, so another rectangle, another bar basically. Then 60 to 90 it is 7, 90 to 120 it is 5, then 120 to 150 is again 5, and 150 to 180 it is f max 8. Now if we are presenting the rows diagram and the bar diagram for the same data set, then we have to follow the same symbols. 0 to 30 degree I have to maintain the same, 30 to 60 were dots. A question to the students: which kind of plot you think is more useful for a geologist, a bar diagram or a rows diagram to plot the trends? You can pause the video and then listen the answer. I hope you really pause the video. The answer is the rows diagram is much more preferred than the bar diagram. The reason is, in the rows diagram, once we plot 30, 60, east, 120, 150 and south and the north geographic direction, it is well demonstrated geographically also, whereas that understanding is not so obvious from the bar diagram. So given a choice in your thesis, always go for this kind of rows diagram. We are going to now see tadpole diagram. This diagram becomes relevant when we are studying the attitude of planes while drilling has been done. Let us say a drilling has been done vertically down, and this geographic direction is east and this geographic direction is west. Now at different depths we are encountering lithological contacts. These can be dipping. For the sake of simplicity, think that either dipping towards east, can be dipping towards west, nearly towards east or nearly towards west, can be vertical or can also be horizontal. Now the tadpole diagram will present three things from here: the dip amounts, the dip direction and the depth at which the different dip amounts and dip directions have been measured. Now one can argue, what if the lithological contact is neither dipping towards east or towards west? Or what if lithological contacts are not dipping 180 degree opposite? This question means that suppose a dip direction is east, another dip direction is northeast. Now east and northeast are not 180 degree apart. Well, in that case the tadpole diagram will not be a feasible presentation of the data set. In other words, in a tadpole diagram we present the different lithological contacts that dip 180 degree opposite to each other. So if one litho-contact and some depth is dipping towards north and another litho-contact at some other depth is dipping towards south, then this can be presented. Or instead of north, let us say 2 degree north, which is approximately north, and here is 179 degree north, which is approximately south, then they can be presented. But we cannot present a data, for example, northwest dipping lithological contact, and going vertically down you come across 10 degree north dipping lithological contact. So in these cases we cannot use the tadpole diagram. We will see once we take some data set and create a tadpole diagram. When we say that the lithological contacts have to be 180 degree oppositely dipping, it means that the strike of the lithological contact is the same. Strike of litho-contacts are same. Consider a cuboid and consider its two diagonals. Now, the diagonal 1 of cuboid and the diagonal 2 of cuboid have got the same strike. This is the strike line of the diagonal 1, this is the strike line of the diagonal 2. Why? Because by definition strike of a plane, for example in this case the plane 1 is an imaginary line of intersection between the given plane and a horizontal plane. This is here that horizontal plane. So, similarly the strike of plane 2 can be defined and these two are parallel. These two diagonals plane 1 and plane 2 have 180 degree opposite dip direction and same strike. So, coming back to the tadpole diagram, what kind of data can be plotted? The lithological contacts at different depths that are 180 degree oppositely dipping, which means they have got the same strike and opposite dip direction. There is no restriction in the dip amount, which can vary from 0 to 90 degree. In fact, besides such planes, horizontal planes can also be plotted and even we can plot vertical planes. So, coming back to this cuboid, we can plot here plane 1, plane 2, say this is the horizontal plane 3, the plane 3 can be plotted, and say this is a vertical plane 4, then plane 4 can be plotted. These are the kinds of planes that can be plotted through the tadpole diagram. Now, let us take a data set suitable for plotting in the tadpole diagram. Consider a drilling, 0 meter is the surface from where the drilling started and serial number 1 stands for this point where the data has been taken, point 2 is over here and then point 3 and point 4. At these points, point 1 is at a depth of 2.7 meter, point 2 as depth 4.7 meter, point 3 at depth 5.9 meter and point 4 is at depth 8 meter. And some lithological contact has been found at point 1 and the dip is 24 degree. At point 2 another lithological contact has been found with 0 degree dip. 0 degree dip means we are dealing with a horizontal plane of contact. At point 3 we are finding steeply dipping contact 82 degree and at point 4 we are getting a 90 degree dip. 90 degree dip means a vertical. Again, starting from point 1, at this point the dip direction of the lithological contact is east. At point 2, since the horizontal, it has no dip direction, that is why a dash is given. A horizontal plane has no dip direction. At point 3, this 82 degree steep dip is towards 271 degree, which is nearly same as 270 degree, which is same as west. Note that west and east are 180 degree opposite to each other. So, there is a scope of using the tadpole diagram to plot points 1 to 3. And what about point 4? It is a vertically dipping plane and a vertical plane has no dip direction. So, that is why a dash has been given here. This we are going to plot through a tadpole diagram. Point 1 and point 3 represent lithological contacts which are dipping 180 degree opposite to each other. In addition, we have two more lithological contacts, one which is horizontal, another which is vertical. So, we have to create a scale. We can use graph sheet. In this graph, I define this side is the geographic west and this side as the geographic east, and over here I define the dip 10 degree, 20 degree and it goes up to 90 degree. This is 10, this is 20 and this is 0. That means we are plotting here the dip amounts. Along the vertical axis, plotting the depth in meter, because here the unit was given meter, and then 1 meter, 2 meters, etc., and it goes up to 8 meter. Now, we are going to plot point 1 first. It is at a depth of 2.7 meters. So, I can use this scale and find out this point. This is 2.7 and I draw a dash horizontal line and the dip amount is 24. So, if it is 20, 24 and I go down here and then mark this point. The deep direction is towards east, that also will be plotted. Since this is the geographic east direction, draw a faint horizontal line over here and I have to draw this 24-degree angle in this way, so that this angle is 24 degree. Once this has been drawn, I have to delete the horizontal line. In this way, point 1 has been plotted and I will write here plot number 1. So, in the tadpole diagram, we have taken care of the deep direction, the depth and also the deep amount. While drawing this line, I redo here. 24-degree angle was drawn from the horizontal. So, this represents the deep of the plane and the deep direction was towards east, that is why we have drawn. If instead of east this given direction was west, how would I have drawn? I would have drawn this circle and the dot, drawn a horizontal line. This is the geographic west direction. So, I would have drawn in this way 24-degree angle, and after doing that I would have deleted the horizontal line. This would have been the plot. Come to point 2. It is at 4.7 meter depth. If this is 2, 4.7 can be over here, and since the dip is 0 degree, the plot comes over here. Note this is 0 degree dip. A 0 degree dipping plane will be represented by a horizontal line. So, when we were drawing here 24-degree angle in this way, in this case it has to be just a horizontal line, and this is point number 2, where the point number 3 will be plotted. Depth is 5.9 meter. So, if this is 4, so this diagram is not going to scale. Say 5.9 is over here and the dip is 82 degree. If it is 90, 82 can be there. So, this is the point. Now, this plane is dipping towards geographic west. So, I have to draw a small horizontal line, can be a faint line, and then I have to draw 82-degree angle. So, that the dip has been utilized 2 times in this diagram. This is important. First, along the x axis I found the dip amount and I went down, and from here the depth line was drawn, they intersected. Then while drawing this small line, this small line, this small line or this small line, again I took care of the dip. Dip was utilized 2 times. And now after drawing this, I will be deleting the horizontal line and this would be the appearance. Point number 4, it is at a depth of 8 meter. So, it is over here. So, I will draw a horizontal line and it dips 90 degree. This time I have to draw a vertical line. Why I am drawing this vertical line? For point number 4, to represent a vertical plane, I will be drawing here a vertical line with the imaginary horizontal line. So, in this way the tadpole diagram has been created. It is an easy one. The exercise for the students is to look at internet and find out free software for tadpole diagram plot, and with this given data set create the tadpole diagram. We are going to see briefly the polar tangent plot, also known as tangent plot of planes. This is less popularly used in stratigraphy and structural geology. The more popular one for the plot of planes and lines is a stereographic projection. Nevertheless, polar tangent plot or the tangent plot has been used in industry. We are going to plot planes. Draw circles which are concentric and maintain these distances OA equal to AB equal to BC, etc. Now, designate the circle with OA radius as 20 degree, the circle with OB radius as 40 degree, the circle with OC radius as 60 degree. OA is equal to 1.7 centimeter, which means 20 degree in my drawing is equivalent to 1.7 centimeter. Now, we draw 2 perpendicular lines, designate one as a north 0 degree, the opposite direction is south 180 degree, and the perpendicular line east 90 degree and west 270 degree. To explain things further, I have drawn a line O capital A in a manner that this angle is 20 degree, that is why I have written here 20 degree. Now in this polar tangent plot, I am going to plot first plane 3 which has a data of 20 degree dip direction and dip amount 20 degree. Here we are going to deal with two information about the plane, dip direction and dip, not the strike. But strike can be understood if the dip direction is 20 degree, the strike for plane 3 is 20 degrees plus minus 90 degrees. This is the strike of plane 3. Since the dip direction is 20 degree, I will move along the OA line. So here this number is the dip direction, and since the dip amount is 20 degree, the OA line intersects the circle with O small a radius at this point. So this is the plot of plane 3. Let us take plane 4. It has 20 degree dip direction, same, so we will be considering O capital A line and it dips 40 degree. This is the polar tangent plot or the tangent plot of plane 4. Now we are going to consider a horizontal plane 1. A horizontal plane has 0 degree dip. Therefore, this point O itself represents the horizontal plane given by 1. Question to the student: plot plane 5. I have already explained you the OA length. Please maintain the same thing in your practical copy, draw things and then draw the plane 5 which has the data 36 degree dip. So this is the dip amount towards 266. This is the dip direction. While using the dip direction, always measure from north in a clockwise direction. If this is geographic north, then east is 90 degree. How do we say? Because from north in a clockwise I have measured. South is 180 degree, west is 270 degree, and from north to north, if I take a complete 360 degree turn, this becomes back to the north geographic direction. Now take any other line, say line M, and this is geographic north. What is the strike? From north move clockwise geographically, and whatever is the angle x degree, this direction is x degree and this direction is x plus 180 degree. X plus 180 degree can be demonstrated in the diagram. From north clockwise, this angle is 180 degree plus x. The reason is this angle is 180 degree. What about this line? This is geographic north. So from geographic north measured in a clockwise direction, this obtuse angle, say small m, that means this geographic direction is m and this geographic direction is m plus 180 degree. So in this way, a dip direction of 260 degree, how to draw? Which means from north I have to draw clockwise 260 degree. This is already 90 degree, this is already 180 degree. So 260 degree minus 180 degree is equal to 80 degree. So from south I can measure an 80 degree angle, and this geographic direction from north altogether is 180 degree plus 80 degree is equal to 260 degree. In this way, the dip direction has been drawn with respect to geographic north in a clockwise sense. How to plot a vertical plane? A vertical plane has a strike, its dip is 90 degrees. Since it is vertical, it has no dip direction. Let us add a strike of this vertical plane north south. Now I am asking students, is it possible to draw a vertical plane with north south strike in the polar tangent plot? Think about it. The polar tangent plot's philosophy is completely different from the stereographic projection. What happens in case of a stereographic projection is that a vertical line plots at the center of the stereo plot, and a vertical plane plots as a straight line passing through the center. vertical plane. A horizontal plane is represented by the peripheral circle. Now, if I compare this with the polar tangent plot, clear difference is found. A horizontal plane is plotted at the center of the polar tangent plot, whereas a horizontal plane is plotted as the peripheral circle. If we plot planes P1 and P2 with same strike, say north south, and different dip amount, the dip of P1 is less than that of dip of P2, and suppose the dip direction is towards east, this is the east geographic direction, then if one watches the great circles representing P1 and P2, the plane with smaller dip is closer to the periphery of the stereo net, and the plane with steeper dip P2 is closer to the center of the stereo plot. Whereas, in case of a polar tangent plot, a plane which is having lesser dip amount is closer to the center. For example, consider plane 3 and plane 4. Here plane 3 has lower dip than that of plane 4, and plane 3 is plotted closer to the center than that of plane 4. So, these are some of the differences between the polar tangent plot and the stereo plot. Another point, in the stereo plot, when we are presenting the planes, we plot them as great circles, such as these two great circles, and they represent planes. And here in the polar tangent plot, we are representing planes as points.